This is a video presentation on our case study on a retaining structure. Greetings, we bid to you, Madam Safika. This is our video presentation. Allow me to introduce our group members, which consists of Faiz Yaman, Jovina Andrew, Gloria Eslincia, Muhammad Shazral, and last but not least, me, Armina Rose. So here are the contents of our video presentation. Number one will be the introduction. Number two, the project background. Number three, the materials used. Number four, the design and analysis method. Number five, the construction technique. Number six, the testing and monitoring procedures. And last but not least, number seven, the conclusion. Greetings, Madam Zafika. My name is Aravina Rose, and I'm going to talk about the introduction to our case study. So, for this project, it involves the conversion of a secondary vocational high school into a vocational college in Labuan, Malaysia. In the context of this project, the gravity retaining wall will be employed to retain and stabilize the soil or other materials around the vocational college site. A gravity retaining wall is a type of retaining structure that relies on its own weight to resist the lateral pressure exerted by the soil behind it. The wall is designed to be self-supporting and does not rely on any external bracing or tiebacks. The key characteristic of a gravity-retaining wall is its weight and stability.
The project background of our case study, which is Cadangan Project Conversion Sekolah Menengah Vocational kepada Kolej Vocational di bawah RP1 RMK 11 Kolej Vocational Labuan, Wilayah Persekutuan Labuan. This project is located in Wilayah Persekutuan Labuan and the client is Kementerian Pendidikan Malaysia, Bahagian Pendidikan Teknik dan Vocational, and the superintending officer is Jabatan Kerja Raya. Types of retaining wall. In the chosen project, there are two types of retaining structure used. The first type is stone retaining wall with level backfill. Referring to the figure, the construction of type 1 stone retaining wall require backfilling work, which involves the work to leveling the slope. Next is type 2, which is stone retaining wall with sloping backfill. This type of retaining wall does not require any works which involve leveling the slope. Comparing to type 1, type 2 have extra member of retaining wall, which is the key in between toe and heel.
So for this next part, I want to talk about the types of gravity retaining walls that is constructed for this project. So there are two types of gravity retaining walls in this project. For the first type, type 1 retaining wall is just a normal retaining wall without any shear key. For the second type, type 2 is a retaining wall in combination with a shear key. So here I have attached two types of drawings that I have screenshot from the tender drawings in stating all the materials used for each of the retaining structure. So now I'm going to talk about the materials used for each of the construction of the major components of the gravity retaining structure. So for the stem, material of choice is stone rubber with the sizing of exceeding 150 mm but not exceeding 300 mm with bricks bonded in cement mortar. For the concrete base, is going to be utilizing concrete grade 25. For the blinding, is going to be utilizing concrete grade 15. So for this project, there's going to be two types of gravity retaining walls in which both of them is going to be utilizing fabric reinforcement, which is the square mesh fabric A142. But for the type 2, there's going to be a shear key. So in that shear key, it's going to be having a main bar reinforcement, which is the high tensile 10 millimeter reinforcement steel bar. And last but not least is the drainage system, which is 100 millimeter diameter PVC with hole.
Greetings everyone, my name is Jovina. Today I will continue with the design and analysis method for our case study. So for the introduction for this slide is about designing. When designing, all relevant parameters and needs are considered and all potential solutions are developed. Then a comprehensive analysis and computations are carried out while considering all aspects, particularly the cost, risk, and uncertainties. The best option is then determined to have the lowest cost. As a result, the decision-making process is rigorous in general. For a retaining wall, it is designed to sustain the earth behind it and prevents a steep face slope of an earth mass from collapsing in cuts and fills, as well as from sliding downward. Continue to our next slide is the design. So for our design, a gravity retaining wall is a retaining wall that relies solely on its own height and weight to stand up. It resists the lateral earth pressure from the soil behind them, which helps to prevent toppling and sliding at the surrounding. The lateral earth pressure is one of the most important dominant forces considered in the study and design of the retain. The angle of internal friction, the cohesiveness of the retained material, the direction and amount of stem movement, as well as other factors, determine the lateral earth pressure behind the wall of the retaining wall. The shape for this type of wall that are used for case study is typically in a trapezoidal shape. The top width of the stem constructed should not less than 30 cm. It is often sloping and wider near the base, allowing them to withstand larger lateral earth forces at depth. This type of retaining wall that are used for our case study is very simple and easy to build, and it is suitable for retained heights of 3.3 meter. The horizontal distance from the wall's toe to its center of gravity is the main element that influences the gravity wall's resistance to overturning. The bigger this distance of our retaining wall is, the less likely the wall will be collapsed. That's all for me. Continue with our next slide is the analysis method for our case study. So, a gravity retaining wall analysis considers bearing, sliding, and overturning forces. Analysis is very necessary to conduct global stability at the site if there are any slopes or surcharges. There are four analyses they need to consider in constructing this type of retaining wall. The first one is sliding, where the retaining wall's ability to withstand the horizontal for acting on the wall. The factor of safety is 1.5. The second one is overturning, where the retaining wall's ability to resist the moment of overturning caused by the rotating forces acting on the wall, and also at the same factor of safety is 1.5. And continue until our next analysis is the bearing capacity, where the soil's capacity to bear the weight of the retaining wall's structure. The factor of safety is 2.0. And the last but not least is the global stability, where the soil's capacity for internal strength to support the entire soil mass is important to analyze to ensure that the retaining wall that are constructed for our case study can withstand forces. That's all for me. I'll pass the next slide to our next member. Thank you.
Stone retaining wall is a structure made primarily of stone or rock materials that is designed to hold back or retain soil. It is commonly used in landscaping and construction projects to create terrace areas or to prevent erosion on slope or uneven terrain. Helps to prevent soil erosion, especially on steep slopes, and allows for the creation of level or usable spaces in areas where the natural topography would otherwise be uneven. These are the construction techniques for stone retaining wall. Number 1 is organize the stone. Sort the wall stones into several stacks according size and form in a crude manner. In irregularly shaped and sized stone can be mixed in with more uniformly sized one to preserve consistency. Number 2 is set up a level line. The position of the front face of the wall's foundation should be marked with wooden stakes and a mason's line. The trench must be not less than half as wide as the whole height of the walls. Number 3 is excavate the area for the gravel base and first course of blocks, which will be below grade. Make a flat, level trench by digging down 12 inches into the earth. Make a 6 to 12 inch wide opening in the slope if necessary, so that drainage stones may be placed between the rear of the wall and the slope. To check that the excavation is level prior to proceed, measure down from the level line. Number 4 is add landscape fabric. Landscape fabric strips that reach a few feet onto the higher level ground should be set parallel to the front of the wall and over the excavated area. Add a 6-inch gap between adjacent fabric strips. Use a utility knife to cut the strips to the appropriate length. Number 5 is build the wall base. 5 inches of compactable gravel should be placed in the trench. Rake the gravel to make it flat and level. Then use a power tamper or a manual tamper to firmly compact it. Over the gravel, add an 1-inch layer of coarse sand with the use of a short 2x4 board to level the sand. Number 6 is lay the first course. To keep the the tops of the stones flat with one another. Adjust the amount of sand beneath each stone as necessary. Verify the levelness of the stones during the work by laying a 4-foot carpenter's level set across many of them. Number 7 is lay the second course. Similar to how bricks are laid in a 1/2 pattern. Position the next course of stones on top of the first, spacing or offsetting the joints between them with those in the first course will strengthen the wall. Place the stones front faces a half-inch away from the slope and away from the front of the first course. This produces a little stair-step pattern known as better, and it helps the wall in fending off pressures brought on by the slope. Number 8 is begin backfilling the wall. Add drainage gravel to the area between the wall and slope. The gravel should be level and racked before being properly tamped using a hand tamp. Only fill in the space behind the wall up to the highest course. Number 9 is install more course. Using the same methods, lay the third and subsequent course of the stones, spacing the joints with the course below and adding a half-inch of better for each course. Install dead man stones, which are long stones which extend back into the slope to help in tying the wall to the soil, beginning with the third course. Dig into the slope and place a dead man every 4 feet or so to make the stones sit level from front to back when necessary. Number 10 is complete the top of the wall. When you get closer to the top of the wall, fold the landscaping fabric over the drainage gravel. To finish the top of the wall, place the last course of stones and the capstones. Use masonry adhesive to bind the capstones to the course below to help in keeping them in place if needed. Number 11 is backfill with soil. Trim the landscape fabric so that it hangs just under the top of the wall. Cover the landscaping fabric and add soil to the area behind the top of the wall, if necessary. The soil layer in this location has not be not less than 6 inches thick in order to support grass growth.
Now I will continue our group presentation on the testing and monitoring procedure of earth retaining walls. So as we can see here in the slide, there are 3 typical testing and monitoring techniques for earth retaining walls. First things first is on the geotechnical investigation. Here are 4 the common approach include soil borings, standard penetration tests, corn penetration tests, and soil classification tests. Basically, geotechnical investigation is a studies to entail learning more about the soil and rock characteristic of the area where the earth retaining structure will be built. And the next testing is on the laboratory testings, where it includes shear strength tests, consolidation tests, permeability tests, and compaction tests. Laboratory testing is a test to offer more precise and true information on the characteristic and behavior of the test. And last but not least is on the field monitoring, where it includes inclinometers, where it can access the retaining structure through displacement or motions, and piezometers, which can determine the pore water pressure present in the soil. So field monitoring is a step to access and monitor the behavior of the earth retaining structure and the surrounding soil, where it entails the installation of sensors. So now I'll pass the presentation to the next person.
So, in conclusion, the gravity retaining wall is a specific type of retaining structure that this study focuses on. In order to maintain soil and avoid collapse or erosion, retaining walls are explained as being constructions. For lateral soil pressure resistance, gravity retaining walls rely on their own mass and weight. In order to prevent hydrostatic pressure, this case study investigates the design, construction method, and the materials used to construct the Labuan Vocational College's retaining structure. So, this is all from us. Thank you. So that is all from us. Thank you for watching, Madam Zafika.